again. Following on from my last video about our new preamp, which is now available for you to spend your hard-earned pennies on and enjoy listening to some really good sound. This is a relatively short video and it's basically a very in-depth technical description of the circuit. And Ron has provided the voiceover in this, so without further ado, over to you, Ron.
Thanks, Mike. Let me explain how the circuit operates. The input section, the first stage, is an inverting unity gain amplifier. The combination of R1 and C1 do not affect the audio band. They are actually good for RF suppression. That's the idea, is to get rid of radio frequency, Wi-Fi, whatnot. R2 is there as a DC restoration, which means that if you don't connect something up to R1, to the input, you don't want the input voltage just going wild, which it would if that was not there. Amplifier itself, R3 and R4 are the same value, so they form a unity gain, but again inverting. And C2 is frequency compensation so that it does not oscillate and so that it has a slight roll off at approximately 130 to 140 kilohertz. Now you may ask, what is R5? Why R5? Well, R5 and R3 are the same value. The reason is because the inputs to any typical op-amp will either source or sink, but typically source, current through their inputs. So what that will do is that will induce voltages into those resistors. And you want those voltages to be about the same so that the output on pin 7 is essentially zero. You don't want to add an offset due to those input currents. Why have this stage at all? Well, because it provides a very low impedance source and a buffered source for the gain stage, which is the second op-amp. Inverts because the second stage inverts. So now the net, of course, is that the output is the same polarity as the input. Now let's move on to the gain stage. R6 and the combination of R7 and R8 form the inverting gain amplifier. The ratio of the value of R6 to the combination of R7 and R8 gets you the gain, the amount of gain. Once again, C3 is compensation. It's essentially the same roll-off characteristics as C2 in the input stage. It's about 130 to 150 kilohertz, well beyond the audible band, but enough to help ensure stability. Here again, we have R9, same as in the input stage. R9 and R6 are the same value. Same reason. You don't want to be inducing DC offsets because of the sourcing current out of the inputs of the op-amps, which seems odd, but that's the way they actually work. C5 and C6 are just simply bypass caps for the power supply. Now to the output section. The output section is quite a bit simpler than we had on an earlier version. It turns out that was way overcomplicated, and this one is actually a lot more stable. Let's start off with just the Q1, which is the QI control or bias control for the two output transistors Q2 and Q3. R11 and R12 are equal in value. Okay, so when you think about what it takes to turn on Q1, how much voltage it takes to go from the base to the emitter, approximately the same amount of voltage is required between the base and the collector of Q1, passing through R11 to induce that voltage into R12. Give or take some, because of course there's the gain of the transistor and some current is required to turn the transistor on, but they're approximately the same. What that means is that the voltage between the collector and the emitter of Q1 will be approximately twice, what the voltage is from the base to the emitter. Why does this matter? Well, look where they're connected. They're connected to the bases of both of the output transistors. Well, as the temperature changes, the base emitter voltage on saturation voltage on Q1 or turn on voltage on Q1 will change, but it will change the same as Q2 and the same as Q3. So they all track very nicely. That means that the QI will not really change that much with temperature. So now, why do we have Q7 or C7? I'm sorry. You look at C7 and you say, what do you need that for? Well, the object is to couple the two bases of the output transistors so that the signal coming out of the op amp appears, the AC portion that is, appears on both of them together and identically the same. You have the offset voltage across Q1, which of course also appears across C7, but basically they track each other identically. So it's good because that way the two output transistors see the same signal. This is pretty much classic AB stuff. Now R10 and R13 supply the current to turn on Q2 and Q3. They also supply a little bit of current to turn on Q1, but their primary function is to turn on Q2 and Q3. Now we get to R14 and R15. Why do we have those? Well, technically you don't have to have them at all, but if you omit them, if you just put wires in there, what will happen is the Q2 and Q3 will become more sensitive to changes in temperature, changes in the voltage across Q1. So what they do is they make it more tolerant of changes in the voltage across Q1. They're not very big. They don't add much to the output impedance. And then the feedback circuit, which goes back from the junction of R14 and R15 back to the gain stage op amp, actually makes it effectively a very low output impedance, very low. So now we come to the output circuit. C14, which is bipolar, by the way, or non-polar, and the R load, okay, all they're there for is to get rid of any DC offset that is created by this circuit, okay? That in practice is only going to be a few millivolts, 2, 3, 4 millivolts maybe. But if you just get rid of it completely, then it has no effect on stages past that, power amplifier stages and that sort of thing. Now, if you want, notice that everything in that circuit is DC coupled all the way through until you get to C14. If you want a totally DC coupled circuit, just put a jumper wire across it, no problem. And you'll get a few millivolts, but nothing really to worry about. Then, of course, you have C8, C10, C11, and C13. Those are just power rail capacitor filters. They are in bypass capacitors. They are completely, I must stress this, completely separate on the two channels. In other words, you have two complete sets of this circuit. You have two sets of voltage regulators. They're totally separate. That's the object of that, is to get the absolute maximum channel separation. So I hope this explains the circuit.